Hi, I'm Cheryl Leach. In this problem, we're going to be looking at the relationship between the graphs of f and the derivative of f. In this particular case, we're given the graphs of the derivative of f, and we want to see if we can get enough information from that graph to find out some information about the graph of the original function f. The nice thing about this problem, or something that makes it interesting, is that there are more than one answer to the problem. Let's go ahead and take a look at some characteristics. Here's my graph of my function of my derivative. Well, what do we know about it? Well, one thing I noticed is that the entire graph is above the x-axis, which means it's positive on the entire interval. So we know that f prime of x is greater than 0 on the interval from -infinity to infinity. Well, what does this tell us? Well, we know that when the derivative is positive, that means my graph of the original function is increasing. So that tells me that f is increasing on my interval -infinity to infinity. Well, what else do I know? Well, not only is it positive, but I know exactly what the value is. I know that the derivative is always equal to 2. Well, what does this tell me? It tells me that the rate of change is constant. Well, what kind of functions have a constant rate of change? Linear functions do. So I know that f is a linear function. Not only that, I know what the rate of change is. So I know the slope of this linear function is going to be 2. So let's go ahead and take this information and see if I can get a graph of that function f. So I'll come over here to my first picture and say, well, I need a line and it has to have a slope of 2. There's no indication of what the y-intercept is, so I'm just going to select something. I'll try the origin. So I have a line that goes through the origin and has a slope of 2. So I'm going to move up 2 and to the right 1 to get back on my line. And when I draw the line in and take a look at it, what do I have? I have a graph that is strictly increasing and has a slope of 2. Well, that's one example. Let's look at another example. Well, the part that was arbitrary in my first case was that y-intercept. So let's put the y-intercept at a different spot. Let's put it at 1. So again, I have a y-intercept. I want a slope of 2, so I'll move up 2 units and to the right 1. And I'll draw in my line. And again, if you notice, it is strictly increasing and has a slope of 2. I bet you could find some other examples that work as well. I hope this helps. Thanks.